this unit, we're going to talk about momentum in higher dimensions. And in last unit, we only talked about momentum in one direction, going forward and backwards. And all of the same theories apply in higher dimensions, but you just have to start treating momentum as an actual vector with x and y components. And it's not that hard. All you have to do is think about momentum in terms of the velocity in x and y components and multiply by the mass. So, for example, if a train is moving at 10 meters per second to the east, and then also 10 meters per second to the north, and it has a mass of, we'll say, 1,000 kilograms, then all you have to do is you can say 1,000 kilograms times 10 meters per second in the east direction would be 10,000 kilograms meters per second of momentum in the east direction, and then the same 10,000 in the north direction, because once again we're dealing with 10 times 1,000. So whereas in one dimension we just took the velocity and multiplied by the mass, here all we have to do is we have to take the velocity as a vector and multiply by the mass. And once again the little arrow means that the quantity is a vector. So when we look at that, it's relatively simple. We define whatever the velocity is, and you can define it based on the angle or based on the x and y components, whatever's easiest. And then you just calculate the momentum from that. And then if you want to do collisions, like we did last unit, all you have to do is follow the three same steps. You have to calculate what the original momentum is. Then you have to calculate what the final momentum is, and that's where you include the variables for the things you don't know. And then you solve for the variables based on the equations you have. And just so this is clear, I'll go over a quick problem about this so you can see what's going on. So for the purpose of this problem, imagine you have a marble with a mass of 1 kilogram heading over at 1 meter per second. And it's into a cluster of marbles. There's a big marble and a little marble. And the big marble's 2 kilograms, and the little one's only 1 kilogram. And you know that after the collision, the first marble has come to a dead stop. The second marble is going up at 1 meter per second. And then you need to calculate what the velocity of the third marble is. And for this one, we'll go through it step by step. We're going to want to calculate this in terms of x components and y components, because that's how the problem is set up. So let's start by finding the original momentum. Momentum equals mass times velocity. The original velocity is 1 meter per second, and it's going in the positive x direction. So that's 1 kilogram times 1 meter per second in the x direction, which is the same as 1 kilogram meter per second in the x direction. So now let's look at what momentum is in the final case. And in this case, what we can look at, we know that our first marble has come to a complete stop, so it's contributing nothing to the momentum. We know that the top marble has 2 kilograms going 1 meter per second in the y direction. And then we know our final one is going in some direction at some velocity, but we don't know what it is. Now we do know that the original momentum has to equal the final momentum. So 1 kilogram meter per second in the x direction has to equal 2 kilograms meters per second in the y direction plus 1 kilogram times some velocity in some direction. So at this point now we need to start solving. We want to solve for the velocity, so first let's divide through by kilograms. All the kilograms cancel out, and we're left with 1 meter per second in the x direction plus 2 meters per second in the y direction plus some velocity v, and once again we don't know what direction it's going in. So after that, it's pretty simple. We subtract 2 meters per second in the y direction from both sides, and after that we solve, and we end up with 1 meter per second in the x minus 2 meters per second in the y direction equals our final velocity. So that's our velocity. It's going over 1 meter per second and down 2 meters per second. So we can sketch that out to see what it looks like. And that makes a lot of sense. We see that the small marble goes flying off downwards. The top marble is bigger, so it flies off upwards at a slightly slower speed. And the first marble has come to a stop, having transferred all of its momentum from here to here. So these two cancel each other out, and the first one goes. And we can do this all because we followed the three simple steps. First, we calculate the original momentum, then we calculate the final momentum, and then we set the two sides equal and solve for the variables. So doing this, you should be able to solve pretty much any momentum-related question as long as you know how it started and know all the stuff that's going on at the end. And sometimes not enough information will be given, but when enough information will be given, this technique does work.